Hi, I'm Destin Eddington,
And I'm Claire Childers.
and we're going to talk about career outcomes in reference to Oakland University, and specifically the role that the Career and Life Design Center plays within those outcomes. And so, an overview of what we're going to talk about specifically is how our goal was to design a data-driven decision-making tool for the Career and Life Design Center through building a predictive model to understand student placement outcomes, along with a dashboard as well, so that way stakeholders could look at a high-level overview of what's going on within the school. Specifically, we want to analyze the relationship between engagement and career outcomes, so place versus unplaced. And we utilized a logistic regression and Excel dashboarding tools in order to do that. Some of our guiding questions were looking at the factors that influenced placement outcomes. Additionally, we want to look at engagement activities and if they improved placement rates, specifically engagement activities that occur here in the Career and Life Design Center. We also wanted to identify at-risk populations who may be, at risk for not being placed and recommend an early intervention program. And we also wanted to know which variables are the most predictive of placement, so that way we could apply more effort and energy into those predictors.
So for our data, we have a couple different sources. Some of our engagement data was from the Handshake Job Platform reports, and we also queried the student information database to get graduation records, and then combined in our placement. So every student that graduates, we give a placed or unplaced, so a binary label based on a survey that we conduct. So got all those files together, merged them all using Python into a single source, and then applied some pre-processing, particularly in the college that the student graduated from, which is categorical, so converting those into dummy variables so that we can do logistic regression on it. And everything else was within Excel. So I implemented a train test split algorithm using VBA just for easy reproducibility and retraining of the model. We initially tried to use the solver GRG nonlinear engine just on all of our features, so 23 different features plus the intercept on all unstandardized data, just as is, and it would run for hours without optimizing very well, and it would just predict a probability of 100% placement for every row, which makes sense because our data is biased with about 64% of our population being placed. So we tried standardizing the continuous variables like GPA, and that did improve it slightly, but it still just was not effective at all. So we determined that the GRG engine wasn't the right tool for the job, and so I implemented a coordinate descent algorithm within VPA, which still uses the GRG nonlinear engine, but it optimizes one coefficient at a time and then repeats it until convergence, or a maximum of 30 times just to get a value. And so with that method, we did get a model that produced something, but looking at our metrics, an accuracy of 65% when the class imbalance is 64% isn't great. The precision isn't incredible across the board, not the greatest, especially in our specificity, which is particularly noteworthy because our original goal with the model was to identify students that are at risk of not being placed, and if it is only catching 4% of those, that's not a very good sign, so not really useful for us. And if you look at the confusion matrix, it's very clear that it was predicting the placed class almost all of the time, with very few being unplaced, and even when it did predict unplaced, it didn't predict very well. So, yep, go ahead. So, but we can still look at the coefficients to at least see which were the strongest predictors. And at rank 1, the all colleges graduate was 2.65 times higher odds of being placed. And all colleges is kind of a catch-all. Not many students fall into that category because it's not really a real category. It's a catch-all. So that being rank 1 isn't really meaningful for us. Now the next few, SBA, SCHS, SCCS, those having odds of 50%, 41%, it is something. But the fact that almost all of the predictive power was in the colleges is not ideal. And then all the way down there at the bottom, the OUWB graduate, so William Beaumont School of Medicine graduates, had lower odds of being placed, which is explainable by the fact that we don't interact with those students, so we don't have much data, and we might not ever even survey them, so they would fall into the unplaced category more often. So some of the other variables we looked at, not very high predictive value or meaningful, and GPA in particular was one that we expected to see a high predictive value, but what we found is that the model, for each standard deviation above the mean, the chance of being placed only increases by about 5%. So that is standardized. So if we unstandardize it, we got a mean of 3.5 and a standard deviation of 0.4. So at the lowest GPA of 2.0, there's about a 17% lower odds of being placed than the average of 3.5. So that's not a massive difference there. Could be explained by it being already partially captured by the college, but that was not what we were expecting to find. So we go to the next slide. Here's the engagement metrics, which is what we were really interested in, and almost all of them are almost entirely negligible. So overall, the model was not very useful for what we originally hoped it would be for. So if we go to the next slide.
All right, so as a result of that, we had to pivot. And so, as what was mentioned, we expected a strong set of predictors from career engagement variables, but our logistic regression showed weak predictive power, with GPA being amongst the weakest, which was really shocking to us. So, taking into consideration like our data limitations also reduced our model's effectiveness, we needed to pivot. And so at this point, we realized that a prediction and proactive outreach system wasn't feasible for the data that we currently had, and therefore our recommendation is deeper analysis. And so we wanted to do deeper analysis on both the data we have and the data we could get. I am going to talk about some of the outcomes, though, in reference to the data that we did get for this project. And so a couple points I wanted to mention were placement rate by GPA. Just a couple stats about that is that placement rate rises from 53% to 53% for low GPA to 67% for high GPAs. So that's like notable in reference to GPA. Additionally, placement rate by GPA and engagement. You'll see some of the biggest lift being in the low GPA group between engaged, non-engaged, and engaged from 41 to 57. And then lastly, our placement rate by applications and GPA. High applications and GPA has the highest rate of placement at 73%. Again, there's an interactive dashboard in our materials as well in which you can toggle items. So our recommendations. Okay, so we want to, again, as I mentioned earlier, shift the focus to a deeper analysis. So investigate students who never engaged with career and life design, but also compare those engaged students versus non-engaged students. Additionally, we want to improve our data quality as well and collect more information about those that didn't engage, because right now, if they didn't engage, we have very limited information on them. Next, we want to add a kind of a different lens of analysis, which was timing. When looking at students, the important part was like when students engage could be as significant as if they engaged.
And so in terms of the modeling improvements, we would look to find additional variables that could be useful in predicting placement outcome, and then cutting those that we've already found aren't really useful or meaningful, and then continue to assess the feasibility of the model, and that can include looking at different types of models, especially if we wanted to include the time dimension. We would need to use something other than logistic regression. So exploring other types of models would be another recommendation.
All right. Thank you.